All right, so you said B, C, and D? All right, so I like this question because it really does go over like basic definitions, okay? And it's one where they actually say mean value theorem, which I find interesting because they usually don't. All right, so Anthony, let's start with B, you said, correct? So find the average rate of change of f over the interval equal to 0. So I'm going to start with the question. So the question says average rate of change of f. So average rate of change of f equals the slope. Does that make sense so far? Let's see. Is the average rate of change on f equal to 0? Let's see. So I feel like that's a mean value theorem of derivative. But hey, let's see. From -4 to 6. -4 all the way to 6. So is there anywhere that you can, and I'm going to do this in a few different ways. Let me think about this. You can't use a theorem because there is, the only theorem I could think of using is mean value theorem. Does that make sense? And mean value theorem won't work because the derivative is undefined here. All right. So let's see. Is the average rate of change equal to 0? Do you understand that if the y values are the same? Okay. Yep. All right. Am I missing something? I feel like, oh, I am missing something. No, I'm not. I'm lying. For how many values? Say that one more time. Oh, I just missed it. This is, I knew that I was like, the answer's infinite, but it's because I missed that. All right, A to 6, so I'm going to change that B into a 6. All right? All right, so it wants me to find from 6 to any other point would the slope be 0, and the only way that that can happen is if the y value is the same. So that would be here, and that would be somewhere back here. Does that make sense? Okay, so then it says for how many values? So 2 values, right? And it's because the slope from here to here would be 0, and then the slope from here to here would be 0. I would probably, all the way over here somewhere. I would probably take a little more time to go through my explanation, but you understand the reasoning? Okay, cool. All right. All right, so that's done. Letter C. From -4 to 6, mean value theorem applied from A to 6. So again, starting from this point to some other point, guarantees at which the derivative is 1/3. So mean value theorem says pretty much very similar to what happened there. So you want the derivative, oopsie, which is 1/3, to be equal to f of 6 minus f of a all over 6 minus a. Same thing, kind of what happened there. Does that make sense so far? So it says, is there an a value for which the mean value theorem applied? We actually just talked about that. Mean value theorem can't be applied because of the corner. Okay? So I believe for that one, you should be able to say mean value theorem does not guarantee. Reason being there's a corner at x equal to 0, which is within the domain of -4 to 6. That should be enough. Okay? I believe so. The question is asking me specifically for which that theorem holds. And the theorem can't hold because of the non-differentiable point. Okay? Good on that one? All right, letter D. And I am going to erase. Actually, no, I won't erase. I will move that over camera. That's just going to look ugly, but let's flip this over. Let me read what it says. Letter D. All right, the function g is defined by the integral from -4 to 6 on what intervals contained is g concave up. So I'm going to start with the question, concave up, right? So that would mean I need the second derivative to be positive. Okay, so let's start with the fact that if I take the derivative of the left side and the derivative of the right side, right? That's FTC. There's a constant on the bottom, x on top, so I can drop that in. Make sense so far? Therefore, to take the second derivative, it would be the first derivative of f. Therefore, given that statement, I'm going to go back here and make f prime sign chart from, where did they say? -4 to 6. I'm going to do f prime sign chart. So, here, it's undefined. I think they told me there's a horizontal tangent at 0. The slopes going up are positive. The slope going down, negative, slope up. And here I'm looking at slopes because it's one derivative away from f. But that's this. Make sense? Start with the question. Define what they want. Move backwards through the information to see how the given is connected to the question. Does that make sense? Good? All right. But I will give you a key and I'll write out my exact solutions instead of just talking through it. Okay? Hikaru? In the, which one, B or D? Mm-hmm. Mm-hmm. This is the interval that they're asking the question. Okay? This is because you're using FTC 1. Remember FTC1, you take the derivative of the left, take the derivative of the right, and then the x goes in. Okay, section 5.4. Okay, whenever you see an integral from a constant to x, you take the derivative of both sides. That's usually the case. It's FTC1. All right, any other questions from this guy? Watching my time real quick. I do have enough time to go over any questions on review 1 then, going back. So, pink, you don't have it? Oh yeah, no, you don't have it. I have it. Yeah, that is what happened to those. Danny, Laura, Anthony, Timon. And I'll give you back your yellow one soon too. I just don't want to do that right now. Davis, Oriana. I should have paused the video. Alright, so this one says, which of the following statements is true about f? Things that I know, just by looking at it, and I see that they're going to ask me about a lot of limits. So, Danny, you asked me this one, right? Is that you? Oh, who asked me this one? 22, I think it was? Oh, I just picked 22 on my own? Oh, why didn't you tell me that? Let me go through the ones that I have first, and I'll come back and delete this out. All right, someone said, where is it? I gotta move forward. That one? All right, so that's an identity. Okay, there's very few identities I expect you to know, but the Pythagorean identities, you have to know them. Okay, have to know that. Given that, I also know that sine squared theta is 1 minus cosine squared theta. If you substitute in 0, it's obviously undefined. If I could factor it, that would be great. I always think of factoring if I see squared terms. A lot of times that's the type of factoring that we talk about. So, goes to 0, 1 minus cosine of theta over 2 times 1 minus cosine square of theta. When I factor it, I have the 2, and then I have 2 factors, 1 minus and 1 plus. Okay? You cannot factor just a piece of the numerator. This whole thing is a factor. What I mean by that is if this was here, and let's just pretend cosine was only here, the cosines don't cancel because the entire term, 1 minus cosine of theta, has to be canceled on its own as a full factor. Factors are multiplied, not added and subtracted. Okay? Added and subtracted are terms. All right. Then there was, moving backwards, the other one that someone asked me, this one. If the graph has a horizontal asymptote and a vertical asymptote. So vertical asymptote is easier. Who asked me this one? David Soriano? All right. Vertical asymptote is easier. It's not factorable. So how do you find vertical asymptotes? Set. But they are telling me that it happens when x equals -3. Does that make sense so far? Horizontal asymptote. Just like end behavior. This is a polynomial. So we always say for your horizontals, just like end behavior, circle the highest power on top, highest power on bottom, and simplify. But they're telling me that the horizontal asymptote is 2. You got your 2, A and C, add them together, you'll get your value. Good? All right, and then Laura, you said you did have another one that you wanted to replace my random question that I just made up myself. I swear I heard this question. What number? 25. 25. I always think it's funny that I get this one because it's common sense. You can actually do it without calculus. It's because it's IVT. All right. So that's why. IVT is just literally common sense, meaning you can get away with just graphing things and checking it. So the notation, let me actually pull this down. So these are your x values, these are your y values. So I'm physically just going to show you a quick graph of them. 0, 1, and at 2, 2. It says f of x equals 1/2. That's a horizontal line at 1/2. Having solutions means intersecting that line. What's the only way that you can intersect that line? Twice with a curve that happens to be closed and continuous. Going from one point to the next, how can I go through the pretty orange line twice? That's what it says. Don't say it as a question. Going under it and going above it. What's the only point, or sorry, only k value that's under it? 0. I mean, I could have done that. Doesn't have to be. Right? This is the y value. Laura, ask a question if you don't understand it. You have to be very careful. You're not going to see this exact problem ever again. So you want to understand why. Because yes, the problem's very easy. Pretty orange line, go under it. Yes, that is how you do it. That doesn't matter. Do you understand? You will never see this exact problem ever again. You won't. So memorizing that won't help. Understanding the fact that if they're giving you a bunch of y values and they want you to guarantee that this y value gets hit twice, it's using us in a sense IVT. Y values are common sense. When you're continuous, the only way y values happen, your mind will understand that. So it's understanding the notation and what it says. It's the fact that this equation, intersecting it twice, really means take the curve and you should be hitting the y value twice. And the only way you can do that is if you go under the y value over the y value. Okay? IVT is common sense. Draw. If it's guaranteeing y values, physically draw them out and see how could you make it happen. Okay? Good? Any others? All right, that's just enough time. So I'm going to go over. Not right now. If I can have time at the end, I will, but I don't think so. So what I'd like you to do is take out your foldable. I am not going to go through many rules at all with you because you have them. It's a matter of just making sure that you do them correctly. 4, 5. Oopsie, one extra. All right, so take out your foldable or you'll be doing your notes directly on. Alright, so I'm going to quickly go over your derivative rules. You don't need to write these because they're written all over your foldable and most of you know how to say them. So if you know for a fact that you don't ever get the rules wrong, you don't need to write it. I just want you to listen. If you're looking at it like, oh my god, I don't ever remember seeing that, then you write it. So this is your product rule. I got two functions, f and g. They're going to be multiplied. So the actual notation, leave the first one alone, derivative of the second, plus leave the second one alone, derivative of the first. So then I just write it for you in the notes exactly that way, just so you have words that help you see it. If you ever see two functions being multiplied, you have to use the rule. And things that don't seem like it's two functions being multiplied, when you see things like h of x equals x squared f of x, I don't know why, but people don't think that's a product rule. X squared is a function, f of x is a function, okay? All right, then I got quotient. Most of you are fine at quotient. If you make a mistake, there's two mistakes made. Number one, you don't start with the right function. It's the lower, low, d of high minus high, d of low all over the low squared. So the first mistake is you forget, oh, I'm supposed to start with the low. And you start with the high by accident. Second thing, since the numerator is so complicated, you simplify the numerator and then you totally forget to copy down the denominator. So you end up with no fraction at all. If you started with a fraction, your derivative is probably a fraction. Probably. It might simplify out, but it probably is a fraction. Okay? All right, those two rules. This one, chain rule. Let's see, start off. So that's the function. Chain rule says there's an inside function. There it is. Okay? So if I'm going to take that derivative, notation is going to be important. This is the real notation. Take the outside function, take its derivative. Lottie, stand up. You're falling asleep. Take a little walk around. Okay? Because you don't need to write this down if you don't need it. Okay? All right. G of x, that's the inside. We're leaving it. G prime of x, derivative of the inside. So that's the notation. Most of you know that. You probably have it written in your foldable. Here's how we say it. Derivative of the outside, leave the inside, times the derivative of the inside. Some of you still, no matter how many times we go over it, you only do two of the three parts. That third part is so crucial. That's the part they're checking. Okay? Make sure you do all three parts. Make sure you understand it's not derivative of the out times in. It's of. This is a big old of. Where's my pen? Not multiply. Okay? I am going to show you one other type of way of writing it, and I'm going to double check if I like the way I write. Okay, yeah. So I'm going to leave it this way. So this one, I'm just going to show you. If you want to write this because you don't have it, you're more than welcome to. I'm rewriting the function as an outside function and an inside function. That really is u of x inside. Just like f of g of x. Same thing. But I'm going to actually take the derivative of f with respect to u. And then I'm going to take the inside derivative with respect to x. And when you multiply those, it actually gives you the derivative that you were looking for. It's a little confusing, but that's actually how you do all chain rules. So what I mean by that is if you have a function, cosine of 2x, your f function is equal to cosine of u, and your u function is 2x. If you take the derivative of this guy with respect to u, that would just be negative sine of u. You take the derivative of this with respect to x, which is 2, and you physically multiply them together. It'll give you the answer to the derivative of h. You actually have done that. You did that at the very beginning. Kind of makes you think of substitution, in a sense. Makes you think of that. Very similar in terms of your u is the inside. Okay? So what I'm going to do with you is 3 problems from that review. They're in the beginning. I think they're numbers 1, 2, and 5, I believe. So let's start with number 1. That one I'm going to walk through with you because most people get very confused on this one. So we're going to walk through this guy. I am very specifically going to do number 1 purposely in a method that you probably wouldn't use, just to show the point of the chain rule, okay? Most of you would probably just go crazy and start substituting things in, meaning you want dy dx. It means you want your y function to be in terms of x. So many of you, what you'll probably do is start from back here and do a bunch of substitutions until your y only has x's. Completely fine, completely correct. You will get a right answer if you don't do anything wrong. I'm going to do it totally different just to show the point of what you saw a second ago. All right? What I would like for you to do is take each part. So y equal to tangent of u. And I want you to take its derivative, not with respect to x, but with respect to the independent variable. So you're going to do it for y equal to, this is u with v's, which means it's u of v. And then the last one is v in terms of x. So each of those, you're going to take the derivatives. And when you're done, go ahead and look up and just double check them. When you're done, double check them. So we didn't do them with respect to x, because then you would have had to do implicit, because these aren't x's. So I did them with respect to the variable that's there. So what they're actually asking you for, here's the question, and what I want you to notice is look straight across at these. So they're written in a way that if you take dy du, multiply it by du dv, multiply it by dv dx, what happens to your du's? They cancel. What happens to the dv's? They cancel, and what are we left with? dy dx. So, how would I do this problem? Take this guy, take this guy, take this guy, multiply them all. But still, it doesn't make exact sense yet. You got all these different variables, so it does look a little confusing. But they're not asking you for the derivative. They're asking you at x equal to e. That always makes a problem easier. It means, no, you don't have to simplify. It means you can substitute in the second that the derivative has been found without making it look pretty. That's what that means to you. Makes it easier. So, what am I going to do? I'm going to work backwards and try to figure out what all of these letters should be in terms of a value so I can solve. So if I know x is e, then here, v is how much? ln of e. ln of v is how much? Thank you guys. 1. All right. Going back. How much is u if v is 1? 0. Let's see. I needed to know what u was, I needed to know what v was, and I needed to know what x was. Do I have everything I need? Yeah. And then when I substitute them in and multiply all 3 across, I'll have the answer. Okay? I'm not saying this way is easier. I'm saying that I wanted to show you that you can take derivatives and physically multiply them in differential notation. And when things cancel, you're left with what's left over. Exactly what I was asked. Okay? I don't know what the answer is. I didn't actually do the answer. All right? No, no, no. You're multiplying the derivatives. You're multiplying the black parentheses. Okay? All right. We good? I'm going to give you a second because I want you to try the next one, which is, I think, number 2? Yeah. All right. All right. Starting with the question is asking me to take, and this one's going to take some space, so I'm going to make this a little smaller. All right. So, in the other class, this was really messy, I think. F of x cubed. All right, so it wants the second derivative, so obviously where am I going to start? With the first derivative. So take this function. Okay, I'm going to take the first derivative. I'm just going to call it y, okay? And so I'm going to call it now y prime. So this is now the y function. I'm going to just ask to take the first derivative. So take one derivative. What rule do I have to use? Chain. Good. All right. Derivative of the outside. Leave the inside the same. multiplied by the derivative of the inside. Anyone have questions so far? All right, so we got our first derivative. Now we would obviously go through and take the second derivative, right? So I'm going to start that process. First of all, we already know because there's an inside, what rule do I have to use for this piece? Chain. What other rule do I have to use? Product. Pain in the butt, but I want to just talk about this for a second. If I take the derivative of the first one, you would end up with this, correct? Look at your answer choices. Is that up there at all? No. So there must be some reason why it's not there. Notice we haven't touched any of the extra information given. All right? We haven't touched that. We haven't touched this yet. Something must be used because I know if I start doing the second derivative, f double prime doesn't show up, it won't be the answer. So I'm going to look at this and say, well, what do these things say? This says take the derivative of f. It equals g of x. Well, did I take the derivative of f? Yeah. So can I rewrite this? G, not just g prime, g. Does that make sense so far? Okay? That makes sense to everyone. We're good. Okay. What I'm telling you is, if you tried to start with that information in the front, you'll probably get lost. It's very difficult if you don't start with the question. All right, so this is still the first derivative. Now I'm going to try to take the second derivative. But I still got to do all my rules. Leave the first one alone. Times the derivative of the second. Plus, leave the second one alone. Times the derivative of the first. Chain rule. All right. I'm going to clean this up. Nine x to the fourth. And I'm going to look up and see, does that show up anywhere? Well, I have one really close, right? But it's not perfect. So I want to double check and make sure I don't make a mistake. I don't just guess. I go back and I say, well, I only used one of the given information pieces, so I'm going to use the second one. It says take the derivative of g, right here. It's equal to f of x squared. So people get confused on that piece. So this should be f of the inside squared. And what do I put in the inside? X cubed. Does that make sense? Because I didn't mean to. I was supposed to do this. We good? So Laura, your question was, how do you think of this? I'm not magical. I don't know when I look at that question that that's going to be the answer at all. And if you guys see me, if I did the answer key a while ago, I won't even remember how I did it. I do exactly what I tell you to do. I start with the question. I write down whatever I can based off the question. So they wanted the second derivative. Does it work in your mind to say, oh, I need the first derivative and I need the second? I think this step right here was a little difficult, but you can still get the answer if you forget or you don't change that to G. I knew by looking at step by step, if I tried to do the second derivative, none of those have an f double prime. So there must be a reason why not, and this has to be the reason. Okay? They don't give you they tend not to give you extra information, they give you information that you're going to use. So most of the time, if there's stuff up there and you didn't use it, you probably made a mistake. But I know, when you see me go through it, you're like, how was I supposed to know how to do that? It just takes practice. When you start to push through the harder questions, you'll notice that the questions get easier. If you filter through and do only the ones that are easy, you'll always think that these are hard. That makes sense. All right, so f of x is x squared plus 1 to the 2 minus 3x. And the issue is you have a variable to a variable. Okay? So I'm just going to answer the question. The other class I had a little more time, so I asked them, what rule would you use? And most people will tell me these two rules. Either a to the u or x to the n. Okay? Because you see an x at the bottom, you see x up as the exponent, you can't use those rules. Reason being, in purple, this has to be a physical number, and this has to be a physical number to use those rules. So it can't be those. So it can't be a product because you're not multiplying them. Right? So the issue is that this is floating up here. Do you guys know any rules that would make it not float up there? The ln. An ln will take an exponent and help you multiply in front. So you take the ln, and I'm going to change the f to a y so it makes it easier. You got to remember that rule. It's really helpful. And because of that, I can bring this in front. Okay? And there's two methods to do this. Method 1 right now, you can do implicit. Meaning, leave it as it is. On the left side, the derivative would be 1 over y times dy dx. And on the right side, I would do a product with a chain. Okay? I'm not going to do that because it's going to take way too much space. But once I do that, I would do dy dx is equal to y multiplied by product and chain. Does that make sense? Which is kind of ugly. It seems like a lot. Make sense? I'm putting blanks here. Is everyone clear on what goes in that box? Okay? That's one method. We ended up having to do implicit because y was not by itself. So your other option, get it by itself. How can I get y by itself? E. Okay? So I'm going to do e to the ln of y equals, you guys can just write a little e if you want. I'm going to write it out. E to the 2 minus 3x. Do you see how it's multiplied by ln? Remember, if you're oh no. I think if you're multiplying it, you can also just do, does that make sense? Oh no, wait. Okay, no, sorry. I might have actually said it wrong in my other class. Alright, there it is. I did say something wrong in the other class. Alright, well, there we go. Totally did it wrong in the other class, I'm just noticing. Alright, so, just so you understand, if you had to take its derivative, huge chain rule, because of the inside, product rule, another chain rule. Pretty ugly, right? There's a way to simplify it. If the ln and e were right next to each other, we could simplify it. But they're not. So what can I do with this? Make it go up this way. Have I taken a derivative yet? No, I'm just doing a crap ton of simplifying. To the 2 minus... Make sense? Did I just go backwards? Yes. That's dumb. So obviously we're stuck there. Then we gotta take the derivative. So you do have to do all that ugly mess. I was thinking about that. That's what I did in my other class. I just realized I completely used the wrong rule. This is the only way it simplifies. Which doesn't help you at all. It's an ugly problem. It's a hideous problem. But it's the fact of what you needed to do to get the x to the x. I'll be honest, most of the ones I've seen have been a little easier. Yes, sir. Go ahead. Yes. Wait, no. No, you end up with the same thing back again. Yeah, you keep going backward.